In a previous episode, we saw how Daria created a tech design for asynchronous processing. In this episode, we will see her code to implement that design. Right, Martin? Martin? Martin?
Uh-huh. In a previous episode, we learned about Listener's self-publishing platform for audiobooks. If you haven't seen that episode yet, you may want to check it out now.
As we heard in that episode, they started to experience growing pains around payments. The first pain point is that users experience a long wait when they place an order.
Daria proposed processing the payment asynchronously to shorten the wait.
She decided to use Cloud Tasks for asynchronous processing. Let's first look at the code in the store service that makes the asynchronous call.
The team built the store service in Node.js. As the service is hosted on Cloud Run, they could have used any language that there is a Docker container for. First, Daria imports the Cloud Tasks library.
Next, she modified the post handler that receives orders from the client. She assigns an ID to the order, calls the payment service, and then returns a JSON response to the client.
This is Daria's function that makes the asynchronous call. It creates a task object with the URL of the payment service, the payload, the HTTP method, and the content type header. It makes things easier on the receiving side if the content type is accurate. She then creates a request object and calls the createTask method.
When you create a task, the payload should be bytes. Daria writes a helper function to convert her JSON to base64 encoded bytes.
Now let's look at Daria's code which receives the asynchronous call.
First, Daria sets up the Express library.
Then Daria writes a simple post handler. For her proof of concept code, she simply logs the order number. In the real system, this code would make a call to the payment provider.
That takes care of responsiveness. Daria also wants to simplify processing of payments for pre-orders.
Cloud Tasks lets you schedule a task for delivery at a later time.
To do this, Daria adds a schedule time element to the task. For this proof of concept code, she simply asks Cloud Tasks to deliver the message 10 seconds from now. In the production system, this time would be set to the release time of the pre-ordered audiobook.
That code simplified the logic for pre-orders. The next problem is rate limits.
During busy times, the payment provider often returns the error code 429. The payment provider docs say that they can accept a maximum of 5 requests per second.
This can be fixed by adding a rate limit to the queue in Cloud Tasks.
Setting a rate limit in Cloud Tasks is easy. Daria simply updates the max dispatches per second parameter for the payments queue.
That took care of all 3 of the payment-related problems.
Daria's proof of concept code works great, but the payment service should be private.
Daria deploys it with a no allow unauthenticated option. Now the payment service can't be called by unauthenticated users.
But the store service can't call it either. Daria creates a new service account that Cloud Tasks can use. She assigns the role Cloud Run Invoker to the new account. This means that this account can call a Cloud Run service.
Next, she modifies the store service so it includes a token for that account when creating a task. Cloud Tasks will call the payment service using that token, which will grant it access.
Excellent. I guess you can go back to your book now, Martin.
Thank you, Brett. I think it was the butler in the library with a candlestick.
To learn about another way of dealing with async processing in Cloud Run, you can tune in to this episode. In the comments below, let us know what you do with queues in Cloud Run, or if you have any questions you'd like us to answer on the show.